This is the question asked in today's SkillTrack Daily Challenge. So we are given a series like this and our task is to find the nth term of this series. So in our sample test cases, in our input we are given the value of n and the 7th term in the series is 17, so we are printing 17 as our output. Now let us see the logic behind this series. So now I have grouped the integers in the series according to the number of bits in their binary representation. So this is just the serial number and this is the actual series. So 3, 5, 6, 9. So these are the series and these are the binary representation of the series values. So the binary representation of 3 is 1 1 and binary representation of 5 is 101 and here 101. So these are the binary representation of these integers. So here I have grouped them according to the number of bits in their binary representation. So here 3 has only 2 bits, so it is in a separate group, and then 5 and 6 has 3 bits, so it is in a separate group, and then 9, 10 and 12 have 4 bits in their binary representation, so they are in a separate group, and then similarly 5 bits and 6 bits. So if you look into the binary representation of every group, we can see that they follow a similar pattern. So it is given in the question that every integers in the series has 2 ones in their binary representation. And the first one is always present at the first. So here also it is present at first, and here also it is present at first, and here also. And the second one is first present at the last, and for the next group element it is present at last minus 1, and then again for the next group element it is present at last minus 2. So like this it keeps on decreasing. So first at last, and then last minus 1, and then last minus 2. So here also in the next group we can see the first bit is always 1 and the last bit is first 1, and for the next it is at last minus 1, and for the next it is last minus 2, and then last minus 3. So all these groups follows a unique binary pattern. So using this we will be able to find the nth term in this series. And also the starting point of every group follows a unique pattern. So the first group starting point is 1, and for the second group it is 2, and then 4 and 7. So it also follows a sequence. So 1 plus 1 is 2, and then 2 plus 2 is 4, and then 4 plus 3 is 7. So the starting point plus 1, 2, 3. So it also follows a sequence like this. So using this starting point and the binary representation, we would be able to find the nth term in this series. So let us see what we are going to do. So let us assume the value of n is equal to 7. So first we have to find in which group it lies, and the starting point of every group was also following a pattern. So 1, 2, 4, 7 and 11. So when the starting point exceeds the value of n, then we would just break and come to the previous group. So here the value of n is 7, so first we would be starting from 1, and then in the next iteration 2, and then 4, and then 7, and once we go to 11, then it becomes greater than the value of n. So we go back to the previous group. So this is the group in which the 7th term in the series lies. And also there is another pattern that is being followed. The first group has 2 bits and the second group has 3 bits. So the group plus 1 is equal to number of bits. So group plus 1 is equal to number of bits in that group. So here the 7 has occurred at 1, 2, 3 and 4th group. So the number of bits would be 4 plus 1, 5. So here we can see that there are 5 bits. Here the starting point and the value of n is same. So we can easily find the binary representation. We know that for the starting point, the second bit with 1 will always be present at last. So we can easily convert this binary into decimal value, and that would be our output 17. Suppose if the value of n is equal to 9, then what we would be doing is we would be subtracting 9 from the starting point. So 9 minus 7 is equal to 2, and we will be shifting this 1 for 2 positions. So in the first shift the 1 comes here, and in the second shift the 1 comes here. So when we convert this into the decimal value, that would be our nth term in the series. So now let us see how to write a C program for this. This is the program I have written. So first I'm creating two integer variables named n and count, and I'm setting the value of count to 0, and then I'm accepting the value of n, and then I'm creating another integer variable named starting point and setting its value to 1. And now I'm creating a for loop to find the starting point of this integer n. So we are creating an infinite loop. So I is equal to 1, and then we have used two semicolons because we are not going to break here. We will be breaking inside this if condition within the loop, and in every iteration we are also incrementing the value of I, and we are incrementing the starting point with I in every iteration, and we are also incrementing the value of count. So this count would be the group in which the starting point is present, and once the value of starting point goes beyond n, it means that it has moved to the next group. So we are going back to the previous group by subtracting the value of starting point with I and then breaking out of our loop. So let us see what we are actually doing. So initially the starting point is 1, and in every iteration we are adding it with the value of I. So the value of I goes from 1, 2, 3 like that. So first 1 plus 1, the starting point would become 2. So here 2, and then 2 plus 2 would be 4, and then 2 plus I, that is 3, would be 7. So like this the starting point would be keeping on increasing. And once when we go to 11, suppose if the value of n is equal to 7, when we go to 11, then we are going to the next group. So to avoid that, we are subtracting 11 minus 4 and coming back again to this previous group, and then breaking our for loop using that break condition. So we would be having the count value. The count value would be the group. So this 1, 2, 3 and 4th group, the value stored in count would be 4. So now for the integer n, we would have found its starting position and also the group in which it lies. So if we know the group, the number of bits in that group would be group plus 1. So which we are doing it in our next line. We are creating another integer variable named number of bits, and we are assigning the value of count plus 1 to it. So all the integers binary representation in that group would be having these many number of bits. So we are creating a character array named binary of size number of bits. So now the first set bit is always present in the first position, and now our task is only to find the position of the second set bit. So to do that, we are creating another new integer variable named right set bit, and then as we discussed, we are going to subtract the number of bits minus the starting point, n minus starting point. So this would be giving us the position of the right set bit, and here we are including this minus 1 because in string we are storing from 0 to 1. So we are including this minus 1. So now we have the position of the right set bit, and the first set bit is always present at 0th index. So we are creating a for loop that iterates from 0 till the number of bits, and in every iteration, if the value of I is equal to 0 or right set bit, we are going to store 1 in the binary array, or else we are going to store 0. So after this for loop ends, we would be having the binary representation in this character array binary. So now our task is to convert this binary into decimal value. So to do that, we are creating an unsigned long integer named L and setting its value initially to 0. And now here we no longer need this value of count, so we are going to reuse it. So we are setting its value to 0, and then we are going to start from our last and go till end, because we have to convert this binary string into decimal. So in every iteration, I am creating a new integer variable and storing the integer value of the character. So if the character is 0, then I am going to subtract the ASCII of 0 minus 48. So in the integer n, we have either it is 1 or 0, and whenever it is 1, then we would be performing our operation to find the binary to decimal value. So after the execution of this for loop, finally we are going to print the value of L. So now let us check our program with sample test cases. So I have given the input as 7, and the 7th term in the series is 17. So we are also getting 17. And now I have given the value of n as 15. So the 15th term is 48. So we are also getting 48. So I have given the value of n as 1000. So let us see what we are getting. So this is the 1000th term in that series. So this is the logic behind today's daily challenge. Thank you for watching.